Welcome to our webinar. Here we like to show you the solutions for 3D plant design from the company CAD partner. Based on the typical process chain in the plant design area, we support every part of this process chain with a specific application. For the Pmid requirement, we provide Smap 3D Pmid. For the 3D plant design, we have Smap 3D Piping. And for the isometric generation, we have the product Isometric. The base philosophy in our applications is not only to support the specific part of the process chain. No, we are focused to use informations and definitions from one product in the next product of the process chain to provide a seamless transport from the information for the user. This is from Pmid to piping, as well as from 3D piping to the isometric generation. Before we start the live presentation, I like to explain some benefits of each product. Let's start with the Pmid application. The Pmid application and the project-oriented user interface allows an intuitive usability of the software. In the software included are large standard symbol libraries based on DIN and ISO specifications. With the integrated component database for metadata, we support the user to create intelligent Pmid drawings. This database is delivered per default as Microsoft Access format, but it is possible to connect also to different database formats if required. A lot of intelligent functions for the Pmid creation and the evaluation of the Pmid drawings support the user. Before the creation of Pmid drawings has finished, a user can use design checks to check the plausibility of his drawings. The next product in the process chain, Smap 3D Piping, also provides a lot of benefits. One important point is the software is fully integrated into Solid Edge. Further, the easy definition of the pipeline passes with 3D line segments of Solid Edge Express Route is a benefit for the user. Because Smap 3D Piping does work with pipe classes, we can reach the highest step of automation for the 3D pipeline creation. This allows the user the fully automatic generation of complete piping systems. The software does automatic place fittings and components in the required situations on the 3D path. If a user have add some additional components to a pipeline, then Smap 3D Piping automatically updates the existing pipeline. Also expanded and reduced situation on pipelines will recognize from the software and automatically generate it correct. We support color, well-OLED and SOC-OLED objects instead of teeth or reduced teeth. If there was a modification of the pipeline path or the content of the pipeline, the software can automatically update the whole pipeline and piping system. We also support welding splits for the correct calculation of the pipelines in later bill of materials. Further, it is possible to generate insulations around existing pipelines. With the explained technology, we also support not round profiles to generate pipelines with not round objects, for example with cable trays, air ducts and so on. The automatic drawing creation is made with standard functionality of Solid Edge. Also, the automatic creation of bill of materials with correct lengths of pipes is made with standard function, but the parameters for this are taken from our generated pipes and pipelines. The last product in this process chain is Isometric. Also, this application provides benefits for the user. With this application, the isometric creation by pressing just one button from the finished 3D assembly is possible. Here the kernel Isogen use all information which we provide to the 3D components, and Isogen automatically creates the required isometric drawings. With the prepared styles that's included in Isogen, the appearance and the content of the drawings can customized 100% user specific. The output of the isometric drawings are possible in different formats, for example in solid edge drafting, in DXF format, DGN or as PDF. After this theoretical information, I like to show you the products and the combination of the products in a live demo. For this we start the Pmid application, Smap 3D Pmid. Smap 3D Pmid is a pure Windows application. For this it has some normal menus and symbol bars. Smap 3D Pmid is a standalone system. That means there is no additional system as base for this application required. But Smap 3D Pmid is no CAD system. That means you are not able to create mechanical engineering drawing with this system. This is created just to design and draw Pmid schematic drawings. The philosophy of the software is project oriented. That means additional to the diagram drawings you can include sheets like cover sheets or index sheets or diagram chapters or some other kind of chapters or lists into such a project file. But the most important content in such a project file are the diagrams. The diagrams itself are intelligent diagrams. That means the content in such a diagram is a combination of some symbols, other symbols, lines with information. Such objects together are the diagram. The elements of the diagram, symbols, lines and so on, are storing the geometric information about the component. But the knowledge about the component is coming from a meta database. This I will explain a little bit later. Additional to this kind of intelligence, we have further intelligence in the application that a user can combine and bring in such a diagram. One intelligent function, for example, is the referencing. That means if you have more than one sheet in such a project file and the sheets needs to connect it together by some symbols, then it is possible by the auto-referencing to jump from one diagram and one specific symbol to the same symbol with the same name in the connected diagram. And in this way you can jump back, and you can do this similar with every reference the system have generated and created for the user during the user creates such diagrams. With this intelligent referencing, it is very easy to come from one process in another connected process. Before you start placing symbols and lines on a diagram, it is normally necessary to include some paper sheets in such a project drawing. Such paper sheets are templates. That means the software works in a lot of situations with prepared templates, for example for drawing sheets or for chapter sheets and so on, which are very easy to use per drag and drop. If such an empty drawing sheet is thrown in a project file, the next step normally is to include some information in the drawing header of such a drawing sheet. And this we can do very easy and also automated. For the filling of the information, it is not necessary to typing some text in such a drawing header. No, this information is coming from some property sheets. Here we differ the project data and the sheet data or the page data. The project data is, for example, a mask that can be prepared with the required information and properties which are valid for the whole project. That means every field you see here listed in the left part of this mask, it is possible to add, edit or remove from this list. Every company can prepare the templates with the property content they like to work with. If a user have to create a new sheet, then these information are pop up from the system and the user can type in the required information. Some of these information can be linked into a drawing header if required. The similar thing like with project data we also have for page data. Here it is also possible to create the own list with the required data fields that are included in this mask and that can be filled by the user with values, and if required such field can linked in the drawing header that the drawing header will automatically filled with information by typing the properties in these masks. After you have inserted some new sheets and filled the drawing header, then you normally bringing some symbols, lines and additional components into a drawing to create the P&ID process. How this works and which possibilities the software giving to the user I like to explain you in the next diagram. In this diagram we like to enhance the existing diagram with further components and further pipelines. To do this I zoom a little bit nearer and now I have the requirement to place an additional vessel into my diagram to enhance my process. The easiest and common way to do this is to go into the symbol library and take the required symbol from this library. A user have access to the symbol library over the symbols function and over the symbol menu or over the short key which is available with this functionality. In this specific case it's the F8 key. By clicking on this functionality, the symbol menu is opening and the symbol menu displays the whole content of available symbols in the system. Smap 3D P&ID is delivered with a lot of standard symbols for P&ID process. The most common standard in Europe is the EN ISO 10628. If I click on this folder symbol and this entry, then I see the whole content of this standard and the depending symbols in this folder. Actually, there are 234 symbols which defined in this standard in our library. But we have more than this one standard in the system available and included. For example, the EN 1868 or the DIN 19227 for measurement and controlling symbols, and there is one common symbol standard, the DIN 2429. These specific folders of the standard name and their included symbols are 100% identical with the standard definition. Additional to these standard symbol standards, we have also common symbols in common folders are also included in the software. For the user, it is necessary that he select the required symbol from one of these available standard folders and then bring the required symbol into the drawing sheet. The standard content we deliver can enhance very easily because it is very easy in this symbol library to edit an existing symbol, to create a new one from one existing, or to create a totally new. And to create a totally new, it is also possible to draw it in our application itself from the scratch, or to import with our Dxf Dwg interface into our software. To select such a symbol, it is very easy. You click just one time and go on OK, or you double click directly and then you get the symbol you have selected on your mouse cross. Before a user places the symbol on the sheet, he has the possibility to control some existing parameters. For example, the scale factor of a symbol, the rotation of a symbol if he needs, for example, an horizontal vessel, or is able to create some individual values by typing if this is required. So the user has the possibility to control rotating, scaling, that the symbol fits to his requirements before he places it on the sheet. When he needs to place it on the sheet, he just clicks on the sheet. And then the next intelligent function of the system comes up. This mask we can see called component data. And in this component data mask, the software requests the user about the unique number of this new symbol. And the unique number to having some specific name, and this tag number here is requested. A tag number to specify a unique number of a component in a P&ID diagram. This tag number can create it by typing in some value or by selecting some used and prepared values. For example, if there is an existing numbering syntax somewhere prepared, a user can select it, for example here with 1 letter and 2 numbers, select it from this list and using a function called nextFree to count up the number which is used in the system to the next free number which is not used in the system. If this is specified, we have did the required work for placing new symbols. Until now we have selected a symbol, we have defined a tag number, and when I go on OK, then the symbol of the vessel with his tag number is placed onto my sheet. What is now the difference between the left vessel and the right vessel? This is very easy to see. The left vessel do only know about his tag number. The right vessel to know a lot more. The right vessel 2001 to know about the component which is used in reality. So how is this made? Very easy. By double clicking on this symbol, we come back to this component data specification mask. And in this mask, we have access to the database. And in this database, we have stored a lot of intelligence about the components which are used in the company. In general, this database is part of the P&ID application. The default format of this database is Microsoft Access MDB. But it can be also in different formats if you have, for example, Microsoft SQL Server or an Oracle server or some similar database applications, then it is possible to connect our application to these database formats. But this is independent from the content in this database. The content in this database do represent the component where a company does work with every day in reality and in the P&ID. We have different possibilities to work with the content. In my case, I have a sample database, and in this sample database I have a lot of different content. I have content which is possible to select by these categories or some main categories and subcategories. And if I select one of these categories, I get in the middle of this mask the data sets which represent one specific component that a company is possible to buy from some supplier and so on. Additional to the category usage, is it possible to make some database queries, some pure and general database queries. For this we have access to database content. All these fields you can see here are 100% customizable. The fields actually just represent the content in my database, but in your database there can be totally different content and fields. Just a few of these fields are mandatory to control the functions of the software. For my sample, I need a description of some component. I need a vessel, and if I search, for example, about a vessel, then you will see that I get a lot of component data sets here in my database. But if I need a specific vessel, I can enhance my query or I can change my query value. 5000. And if I create a good database query, then I come to a minimum set of results, like in my case a vessel with 5000 liter. The general meaning of this database is, here in this database a company is able to prepare the component knowledge where the Pmid application and the Pmid process engineer does work with. Normally this database is not created from the scratch by typing in some values. No. Normally this database is filled by import. For example, if you have a PDM system, an ERP system, and warehouse system where similar data sets included, then it is normally possible to export from these systems to an Excel file or to an XML file, and these files or these sources are able to import in our database. It is independent if it is Access or if it is SQL or similar. About the managing and the preparation of the database I explain at the end of this presentation. But for now, let's go back to the user point of view. And the user point of view is, here is a content about a component that is required for the symbol. And when I double click on this entry or I click on OK in this mask, then this data set from the database will associate it to the new symbol with this new tag number I have included in my Pmid system. And here is also another additional possibility that I like to explain you. For example, if you have the requirement to include some external data sheets, some external files, then you can do this. Then you can prepare the database with such an information, and every time a user does work with such a data set, he has directly access to these external data sheets. In my case, it is a PDF data sheet of the real vessel component. This functionality is optional. That means if there is a requirement in your company to work with such external sheets, to handle such external sheets or such external files, then you can do this. If we close this mask, we come back to the component data of the symbol that I have included. And here we can see some of the associated information from the data set. But not only this content is associated to the symbol, the whole content from the dataset belongs to the symbol I have associated to. If I click OK button here, then we leave this mask, and now we can see all available information are now belong to the component. And from now I am not only a stupid symbol in my diagram. From now I have an intelligent component placed from the symbol library together with the dataset from the database into my drawing. And this is a general workflow for every component, for every symbol we have to place into our Pmid drawing. To go further, I enhance the drawing now with additional content. And for now, we like to include some pipelines. Similar to the symbols, what we can select from the symbol library, we are able to define the lines we need to draw every time we need some line. So here, for example, the lines functionality, I can start by a click on it, and then I have the possibility to select the required line style, to select the required line width, to select the required line color. So if I need a new line, I can define it here in this symbol bar. But more effective and more powerful is to redefine the most important and the most used pipelines and bring it as favorites or bookmarks to the system. And for this, our Pmid application have the possibility to create such pick menu registers. Every register you can see here is available because it is created by the user. Every user can create his own pick menus with his own favorites, and there is no limitation about the count of such pick menus. And like we can create pick menus with symbols, we can also create pick menus with the required pipelines. For example, a black pipeline, a blue pipeline, an orange pipeline, a green pipeline, and so on. but these actually now only represent the pipeline color, the pipeline width, or the line width. To make from the scratch an intelligent pipeline, it is possible to associate to such a pipeline favorite also a data set from the database. This was made, for example, with the red pipeline. If I go to the red pipeline, then such a list appears, and in this list I have access to the associated data sets which prepared to my red pipeline. And so if I select one of these entries, for my case I need a pipeline warm water diameter 80 with spec 900, and with this selection I have directly access to create a pipeline by clicking here. And during I draw the pipeline I have access to draw an horizontal and vertical. I have different kind of lines. I have straight lines, I have slanted lines, I have angled lines. So a user can select which kind of line he wants to draw, and this does influence the geometric. But after the pipeline is drawn and after lines are recognized as one pipeline, and I open the pipeline or the line article data, then I can see that some of the informations are assigned without some additional work to do. And this is done because I have prepared my bookmark pick menu here. So after I have drawn this pipeline and I have selected from my bookmarks with this information is prepared, then I only have to define the tag number of this pipeline. And here I can do the same like for the symbol. I can, for example, type in some values, or I can say I like to have access to some use numbering systems. Here can I say, for example, I like the same typing like here, but the next three number of the pipeline, and then the software counts up directly. And what's now the benefit of the favorite pick menus here is, for the moment it is not necessary to select from the database these entries, because they are prepared. So then, with this normal definition of the pipeline tag number, I can finish my pipeline creation process. And with OK, I come back to my drawing and I see that this tag number now is visible on the line. But additional to the tag number, I can see in this small rectangular field all the information which is specified with the pipeline. In the next step, I like to create the second pipeline at the lower part of the vessel. And for this, I do the same workflow. I select my prepared favorite warm water pipeline. I select my nominal diameter and my spec, where the pipeline is generated with in 3D. Then I draw my pipeline. And with the connection to the object data, I have access to the assigned information, and I can also define my new pipeline tag for this. Here I use my existing numbering syntax and count up to the next three number for 136. And with this I place this number, but all additional informations are available with the pipeline. The lines we have drawn are normally connected to the symbol where I have connected it. So that means if the symbol, like in this case the vessel, is moved, then the lines automatically moved with the symbol, and the connection point and the orientation of the line is aligned and oriented fully automatically. In the next step of the presentation, I like to place some additional components into the pipeline. For this we need some valve. I can take the valve from the symbol menu, or I take it in the same way like with the pipeline. That means I take it from my favorite pick menus. And here, for example, I have a pick menu with my most important and favorite valves. And to every cell you can see here, I have placed the symbol and I have assigned a component data set from the database. But there is a more possibility than just assigning one component. Like for this symbol here, I can, for example, assign more than one data set to one symbol. If this is done, then you get such a green little edge in such a cell, and such a green little edge is the indicator that there is more than just one entry assigned. But if you need the same globe wealth all the time and just one symbol with one dataset, then you grab the dataset and the symbol together from the pick menu. Then you can control the scaling, you can control the rotation. And if you like to place it into our pipeline, then I just have to go over the pipeline, click on the pipeline, then the software asks me again about the component data. And the only thing a user have to do is giving the tag number. And if he like to have a totally different tag number, then I select a kind of tag number from the used names. Using the next free functionality, and the software automatically count up to the next free number. And I'm not able to making some mistakes by counting or creating two different components with the same tag number. With click on OK, I will see the result, and the result is that the symbol is placed, the whole dataset is assigned, the tag number is placed with the symbol, but this numbering or this information, this text annotation, is possible to change to a required position afterwards. That means if the prepared position is not good for the moment or for this situation, then a user can move it to a position where it is better. For the next pipeline, we need also a wealth. We need the same wealth again. And for this placing, I use a common 2D functionality like copy, like moving, like pasting, and so on. All these common functionality of a 2D system we have also in our P&ID application. And when I need, for example, a copy of the available symbol, I use the copy functionality. I'm able to move a copy of the symbol to place it here. The software is placed with the same tag, with the same assigned data set, and I only have to count up to the next free number for my symbol. And if I go on OK, then also this symbol is placed with his new tag number to my pipeline. And every time I do this, the pipeline is broken. That means the pipeline is broken at the position where symbol is placed. With these explained workflows, I can enhance any diagram with more components, with more lines, till this point where it is finished for the user. For my diagram, I need to have an instrument on the vessel, and here I can also grab a favorite from my pick menu and say, okay, I need to have a symbol like this. I select it from my pick menu, connect it to an available connection point on the vessel, count up the tag number, and controlling the symbol data. If it is a pressure instrument, for example, I select it here, and if it belongs to the vessel 2002, it gets the same number. Go on OK, and then this pressure indicator is placed. So like I explained, if this diagram is finished for me, I can, for example, go by the reference to the connected diagrams, can do some controlling, can go back to the other diagram, and if everything is okay, I can go further to do additional things with my diagrams. One next work, for example, can be the inserting of a new sheet. This is, like I explained at the beginning, very easy by taking some templates from the template folder, selecting it, drag and drop it into my project, and then I automatically get a new diagram, a new sheet, which is listed in my sheets with a new register. You see some of the drawing header content is filled from my project data or my page data, but in this case by the project data. These informations are linked from here to the drawing header. The page data are empty because they're not filled, because it's a new page. And in this way I can now create a new diagram or an additional diagram if it is required. In the same way, like I can insert a new sheet as a diagram, I can also say I like to insert some report templates to evaluate my existing diagrams. If, for example, I need a bill of material from this diagram or from all diagrams which are in my project, then I can create reports from it. A normal report can be a bill of material. For example, like this, a bill of material where the quantity is counted for every occurrence which is placed in my P&ID. How does such a bill of material is created? This is very easy because it works similar to the inserting of new sheets. Here, for example, we have the templates for part lists, and if I need a new part list, I select a prepared template. Then I drag and drop it into my project file. It is listed as a new tab in my tab count or in my tab bar here. Now it is empty, and with a click on right mouse button I can say update this list, and I now get the evaluation of all my available diagrams. If this is too much because I just like to evaluate, for example, the diagram number 2, then I have the possibility to change this. With the list settings I have access to all criteria and information where I can control the list. If, for example, just like to include the page 2 into my list, and I can select here from my page menu that just the diagram 2, that is a diagram I have enhanced minutes before. I go on OK. The same I do here by typing. Now I go on update, and now I see that the list is shrink and just the content in the list is available that now is on diagram number 2. If there is an entry, for example here, where no content is displayed, then it means that there is in the quantity 2 a content in the diagram which do not have some assigned data set. And if I like to solve this, I can do this very easy. So I go to my sheet back and use a function called object lister with the short key and the F7 button. Then I come in this mask, and in this mask I can select the display of all available symbols. In this object lister I can, for example, sort about every available column, and if I like to see here all the content of page number 2, then I can see this, and here in the other columns I can see all other information which are available. And here, for example, you see 2 entries where no data set is assigned, and this seems to be the content which is in the bill of material but without an information. To solve it now is very easy. I click on the entry, go to object functionality, and I see in the diagram where this pump 2001 is placed, and with a double click I come to the data information, and here I see there is a data set missing. And that's the reason why there is no content displayed in the bill of material. With a grab to the database I go in there, and here I can now, for example, search in my structure, in my category structure, or I can create a database query. Independent how you do it, the meaning is you come to the dataset where you like to use, for example, this centrifugal pump. With a double click I assign it here, go back to my object lister. Here the information is assigned. I do the same with the other pump. Double click on the symbol, it's also empty. I assign the same with OK. Go back to 7. So in this lister I have the information that now all data sets are assigned. We can close this, we can save this. After that we go back to the list. And now when we back to the list, the software automatically update the bill of material with the new information, and now we see the new assigned data set here listed in the bill of material. And this bill of material is a normal quantity bill of material, but we can do additional changings if we want to have a better overview. Then we can, for example, doing some sort functionality, perhaps with a line between, go on update, and then we get a better sorted or better displayed bill of material for this kind of list. Another kind of list is the component list. The component list is different to the bill of material list because in the component list every component is listed and displayed with his component name, with the tag number. And that means if you have more time the same component, then you have more similar rows but with different component names. And that is the meaning of component list. If you need such lists as virtual sheets in your project, then you can insert it with such templates if required. If you do not need such virtual sheets, list sheets in your project, if you just need the export of the information as file, then it is also possible with our Pmid application. Then you can directly export such lists as files. Here we have part lists, we have component lists, we have also connection lists, possibility to export. To explain how it works, we select the part list file, and here we get this configuration mask for the user. And the meaning of this mask is, in this mask a user can define which information he likes to export to a file. For this it is possible to create or load format files. Here for example I have a format file in German language and I like to take one for English language. Now I open this format file and we see that this information is now defined. But let's change it a little bit. For example, the item code should be at the beginning, or also the ID should be at the beginning, then the article number, then we have a description. The standard is not necessary, but perhaps we need the type, we need the nominal diameter, we need the pressure if it is available, we need, for example, the manufacturer. All this information you can see in the left window are information from the system and from the database. You can configure as content of your export. This you can save in your format file. Then you can select the format export, the export format, the file format. Here we support XML, Microsoft Excel, column separated text files or comma separated text files. Depending on your selection, you get here the extension of your new file. And if you click on the OK, then this new file will create it in the prepared list folder. And with a click on OK, this file is generated. Perhaps you are requested to save your format file. Can so yes, and if this function has finished, then we can look into the file folder, the list folder, and here we see our export, and now we see all the content that we have exported by do the export with our list export. So with this functionality, a user is able to export any information which is available from the diagram with the database knowledge to some external sheets. With the same technology and function, we have also created and developed our interface between the Pmid application and Smap 3D piping to create the 3D pipelines. Before we switch to the 3D, I like to explain you further functionality in our Pmid application. And here I like to explain the creation of symbols in our system. First, switch to the symbol menu. And like I explained, here in the symbol menu, you are able to edit symbol or to create new symbols. When you like to create a new symbol, then you can do this and you come automatically into the symbol environment. This is shown in the header of the window and with this linking symbol entry here in the symbol bar. Here in this window I see the reference point, that means the origin of the symbol, and with the integrated functionality for lines, for text, for circles and arcs, I can draw my own symbol geometric. I can start the drawing functionality, go to the reference point and have the possibility to draw a symbol. During this drawing, in the same way like in the diagram, we have a kind of grid and a kind of snap, and the values for this I can control here over these values. What is also possible to display the grid if it is required. For this I can go to the settings and can display the grid with dots. And here I see the dots and the grid, and now I can start drawing my lines. If I like, for example, draw my lines in this way with red lines, then I can start drawing. And in this way every user is possible to draw his own symbol geometric. At the next step he has to create the connection points. The connection points must belong to the symbol, and the connection points do identify the point where it's possible to place a line or a pipeline. These connection points I have to place on the symbol geometric, and I have to name them, because normally the connection point on the real component do also have his numbering. So I can say this is symbol 1 and this is symbol connection point 1 and connection point 2. If this is done, I now have created my symbol. If I like to change the color of the symbol, then it is possible by switching the color, for example, to black, and then it is black. Now I have a black symbol, and if I not like to draw my symbol geometric by my own, I can delete it, and for example I can say, okay, I like to load my geometric from an external source. And here I have the possibility to import Dwg Dxf files with this external interface and use this geometric from blocks or from groups or from some other geometric Dxf Dwg into my symbol, and with this I can use the geometric from external as symbol here in my software. To do this I normally have to specify the import or export interface for Dwg or Dxf files one time. In this I like to explain you now. For this I close the symbol creation without creating a new symbol, and as next I go to my tools menu where I have access to the Dwg Dxf mapping settings. In this functionality I come to my map options, and in this mask I am able to create a mapping configuration for specific sources. In this map options you have the possibility to set the export information and the import. You see, for import we have more possibilities, because in the import we can use more intelligent functions. Here I can, for example, load some existing drawings. And if there is a DWG file, it will analyze, and with this analysis I can go in my next steps. I can, for example, see if there is a color in my source file which is not assigned or not specified here, then I can do it here, or I can do with the line styles. I can say, okay, continuous in my DWG source should be solid in mine, or the middle should be dash dot, and so on. And in this way I can do the assignment or the mapping between the source file with my Pmid application. This I could do with layers, for example. If there is a layer and we like to map the layers together, then I can say, okay, this layer should be on layer 8, and so on and so on. And with these options you can do all required mappings, and this you can save as map file, and with this map file you have access to these settings every time you would like to import some files from the same source. So this is what I like to explain you about the possibilities to doing some imports. At last, before we go to the 3D, I like to explain you our administrative database application. For the database managing and the filling of the database, we have our administrator console called Smap Pmid database. Here in this database application we have the possibility to connect to an existing database, to load the database, and to look in the content of the database. This is displayed in different possibilities. We have the possibility to look at the record view or at the table view. So here we actually are in the database content. So that means we see, for example, all data sets which are defined to such a category. If there is a category where not as much data sets are assigned, then you can see it here. But you can also work without this category view. Then you can say you just want to see all records which are available here. And here you have access to all the content which is specified in the database, and you can modify this content. That means you can copy some records, some data sets here, you can duplicate it, you can delete it, you can move it, you can do a lot of customization with such data sets. But the most important functionality of this database tool is not to changing some specific data sets. The most important functionality is the possibility to do imports and exports. That is what I explained in the presentation itself, with the meaning that normally a database is not created by typing from the scratch. Normally we import some files from external sources, and here we have a lot of possibilities how we can import such sources. And like I explained in the presentation, normally we take the information from existing PDM system, warehouse system, ERP system, where an administrator or some automated interface creates some export from this system, and we create the import to our system. And then it is very easy to fill the required database with your required content. There is also an API in this application and also in the database application where we can do, for example, the developing of specific synchronization tools or applications. Now I like to close this. And now we come back to the Pmid. And with this Pmid drawing, we now like to go into the 3D. And in 3D, I like to show you the creation of 3D pipelines controlled from the content and with the information from this Pmid drawing. For this we open an existing solid edge assembly. This 3D assembly represent the state of the plant before we did the enhancements in the Pmid during the demo. The main components in this assembly, like the framing or the heat exchanger or the vessel and so on, are created and assembled with pure and normal solid edge functionality. That means the framing is made with the frame functionality. The heat exchanger, for example, is imported from a step file from a supplier web page, and the vessel, for example, is modeled and created with pure solid edge modeling functionality. All these components and equipment things are necessary to create and assemble before you start creating the 3D pipeline creation, and it is done with pure solid edge functionality. Just the creation of the pipelines itself, for example this pipeline or that pipeline, this is made and will made with Smap 3D piping and the connection for the knowledge from Pmid, which is a part of Smap 3D piping. Before we start with the creation of new pipelines in this assembly, I like to explain you the requirements which are necessary to do 3D pipeline creation with Smap 3D piping in Solid Edge. The first important point which must be available before we start the 3D pipeline creation is the library with all required components. That means with equipment, with valves, with fittings, with all the parts and assemblies that you like to use automatically during the pipeline creation with the piping software from us. If parts of the library or the whole library is not available or valid for your requirements, then Smap 3D piping can't create your required pipelines automatically. From the software products you can buy from us, there is also a library available where fittings based on standards, DIN, ISO or ANSI or other standards are included. Also the tool which managing the library is available as a product from us. This tool is Part Finder. This is a mask that appears for the user at the first usage of the Part Finder tool. This Part Finder tool does manage the library and the content of the library. In this Part Finder mask, a user has the possibility to view and select the content in different ways. One way is a visual navigation, the next is a category navigation, the navigation by a specification, and there is also a query possible, which is a little similar to the query we can do in the Pmid application by query some values in the database. But the most effective way to view and search something in the library is a category view. Here you see, for example, some categories called DIN or ISO or also US standards. And additional to the normal standard categories which come delivered from our piping library are the categories which user specific, perhaps the purchase parts with instruments, valves and so on. And here are components listed which not delivered from us in the piping library package, but every user and every company can include their specific and required supplier parts or purchase parts or similar things in this database. A detailed list with the standards we can provide to you is available on our website, for example for the fittings, flanges and so on. If you have selected such an end category in the category view, then you get in the middle part of this mask the overview and the selection possibility of all available variants. If you select, for example, a specific characteristic here, then you have perhaps additional characteristics to select, and at the end, if the selection is done, you see here in 3D preview, which is possible to rotate, and also a 2D preview with additional information is included for all the components which come from our library. And in the lower part of this mask you can see the available properties to the selection in the middle part you have done. Normally this mask will not used from an end user which like to create the 3D pipeline. Normally this mask is just in use from a key user or administrator, which have to prepare the library and also which have to prepare the pipe classes, which I like to explain you now. The pipe classes are the second important part which needs to be prepared before a user starts the automatic 3D pipeline creation. These pipe classes are possible to create and to manage in our piping application, and all these functions belong to the piping product itself. This is a mask of Smap 3D piping application. With this mask, a user later creates a 3D pipeline. But in the menu pipe classes, there are all possibilities available to prepare and create the pipe classes, which are the base of the later 3D pipeline creation. Let's start the pipe class editor. At the first start of the pipe class editor, this mask does appear, and it looks like a kind of a table view. But this is actually an empty table because there is no pipe class opened. Let's open an available pipe class. For this we take the pipe class which we also use in the Pmid to specify the 3D pipeline creation with this specific pipe spec. In this open pipe class we see a lot of rows and several columns which are filled with values. Every row do represent one component which should use automatically from the piping application to create 3D pipelines. Every row does represent one specific component. And here we divide the rows which are colored with a light green. These rows are the general definitions, for example, to which standard situation on a pipeline, to the tube or a pipe standard situation, to the band 90, band 45, T and so on standard situation, and also to the definition for which diameter it should use or which pressure, and also included is the definition which specific 3D model from the 3D library should use for this defined situation. And here we have different models for different situations. And this is a one-to-one specification which does represent the required content that must used to creating 3D pipeline. In this mask we have the possibilities to sort or to filter to specific values of the pipe spec. And with these functions, for example, you can have a better possibility to manage and control the content which should be displayed or the content you like to use for some changings and similar things. Like I explained before, in such a pipe class there is a specification from one specific 3D model to one specific situation which is used for an automatic creation of 3D pipeline. But in such a pipe class there is also the possibility to specify and define components which are not able to use fully automatically, but the definition makes sense to use it interactive and in a kind of manual communication between the software and the user to place it also easy and fast from the pipe class process secure into a new 3D pipeline. In this case we have a butterfly valve, or similar to that you can specify ball valves or any required keyword, we call it keyword, for example stop valve. So that means the component which is specified here to such an additional keyword it will use in a later step at the creation of 3D pipeline through the user when he places it additionally. Additional to the one-to-one definition, we are able to define additional parameters which control the behavior of the pipe class and the software at the later pipeline creation. Here we have the settings about maximum length definition, minimum length definition, band radius, welding splits, insulations, and also the settings about the behavior when you work with shaped tubes. That means with not round profiles to create a kind of pipeline, for example for air ducting or cable trays and so on. In every of these masks the user can define if he likes to work with this specific parameter, here for example with the maximum length, and he can also define a specific value for a general use or different values for different diameters which are used in the pipe spec. For specific, the maximum length values does control the behavior of the software, which should happen if a maximum length of a straight tube is reached. Should there just be a welding split between one tube and the other, or should there be no welding split, or for example should there placed an additional component like a coupling, like a screwed union and so on. All such things and such behaviors we can control with these additional settings, which are able to do in a pipe spec. For example, the setting of the bend radius allows a user to define if he likes to have banded tubes instead of the placement of elbows and band fittings. So here a lot of combinations are possible, and normally with these settings we can reach every requirement of a user to control the behavior of the software to his required things. So the general meaning of this pipe spec is that every definition an administrator does create and define here does control the software to the requirements of the user and the company. And if such pipe specs are defined correctly with a specific name, then a user which create the pipeline can work only with the specification, and if this is done, then he is 100% process secure to the definition he work with. This is a second important point that should be available if a user should start creating 3D pipelines automatically. So let's summarize the requirements that should be available before a user starts creating the 3D pipelines. At first there should be a 3D assembly as a solid edge assembly where all required components and equipments should be placed and included. Then the library in the background must exist, and additional to that the pipe classes should be available for the end user. If this all is done, then an end user can start the 3D pipeline creation with the piping software. Here we have the possibility to work standalone without a connection to Pmid, if for example the Pmid is not required in your company. But especially in this webinar we like to show you the workflow and the behavior when we work with the connection to the Pmid, and the Pmid we have created and enhanced in the demo before. To connect to the Pmid, we start the function Pmid to-do list. This new interface does connect to the existing Pmid drawing. In the mask, the software does analyze the content of the Pmid drawing and does display it in my 3D assembly. Here you see the assigned Pmid drawing which belongs to this 3D assembly. The setting about this is made as I start to creating the first pipelines here. But if you start this application new the first time you create a new 3D assembly, then the software requests you to set a Pmid project linked to this new 3D assembly. In this mask the content of the Pmid project is analyzed, and here we see also the content which is in different sheets in the project. Especially for our assembly we just like to use the sheet number 2 of the Pmid project, because just this sheet number 2 content does fit to this assembly, and for example the content of sheet number 1 does perhaps fit to a separate 3D assembly or a main assembly where this is just a sub process. If I open this structure, then I see a lot of entries. Every entry does represent one pipeline which is defined on the Pmid project and which should created or is created in the 3D assembly. We see the information about the pipeline number and about the diameter which is specified and defined in Pmid for this pipeline. These first entries do have a green check. That means every pipeline here which have a green check is actually existing and created in the 3D assembly. Let's take a look to the end of this list. Here we have entries which do not have a green check. That means these entries and these pipelines are actually not created in the 3D assembly. And these both entries are the pipeline we enhanced in the Pmid during the demo. Below these entries we see the content of such a pipeline which is delivered also from the Pmid. That means every entry below of a pipeline do represent the content which is required and which is defined on Pmid level and must exist also in the 3D assembly of the pipeline. In this rectangular field we see all the information which are delivered from the Pmid with this interface into the 3D assembly and which can used for assigning and linking information from Pmid to the 3D content. Every company with a green check do represent and display a component which is known and which is placed in this 3D assembly. So for every available pipeline with a green check I also have placed and included all required components, and this is displayed with a green check in this mask. Every component which have a green check and I click on it in this mask is highlighted in the working window of Solid Edge, and I can see where this component is placed and how does it look like. This behavior is valid for every entry, and if every entry of a pipeline do have every component with a green check, then it means that this state does totally fit with the definitions of Pmid. But let's take a look to the entries which do not have a green check. Here we see on the first view that we have to create the pipeline to fit with the Pmid definition, and also that we have to place additional components to the pipeline to fit to the Pmid definition. If there is an entry which do have a green check, then it means this entry is known from the Pmid interface in the 3D assembly by defining in a step before, or because it belongs also to another pipeline which does exist at the moment in the 3D assembly. The content without a green check we now have to create. Here for example take a look at the entry B2002. This entry and the information about this entry means it's a type of vessel, it's an article number. This entry does represent our 5000 liter vessel which we have placed and enhanced in the Pmid during the demo. Now we have the requirement also to bring this component into this 3D assembly we actually work in. And because a vessel does normally not belong to a pipe class specification, so we have different way to place it. The normal way to place some kind of outer equipment, for example a vessel, is to import it or to model it in Solid Edge and then to place it into assembly. These I have done before. So let's take a look into the edge bar in the Pathfinder. Here a vessel is actually placed. This is a 3D assembly of a vessel, and this assembly is placed and positioned with constraints, with normal Solid Edge constraints onto my framing, and with this 3D vessel is fully positioned in my Solid Edge main assembly on the framing which does exist before. this is one way how we can place assemblies or components which belong to the outer equipment into an assembly without the usage of pipe class specification, because normally such components do not belong to a pipe class specification. So if we now have the 3D assembly placed in the assembly, then we just have to assign the information from the Pmid level to the 3D model, which is now part of my assembly. And this workflow is very easy. So that means if I click here on Pmid level on the entry, then I have the possibility to assign all the information which are delivered from Pmid to this selected 3D assembly that I have placed in a separate workflow into my assembly. If I use this functionality, then the software does assign all required information delivered from Pmid to the model. I get the information that it is done, and after it is done, my component do get a green check. That means from now it is known from the Pmid point of view in this assembly. Theoretically, the same workflow we can do with the next entry, which needs to create it in our 3D assembly. But if we look to the information that displayed from the Pmid, we can see that this is a valve. And a valve you normally handle different than an outer equipment like a vessel or like a heat exchanger or similar things. A valve normally belongs to a pipe spec, and a valve normally will placed into a pipeline when the pipeline does exist, and then it normally belongs to the inner equipment. So this I will show you in a later step when we have created the pipeline itself. So to create now the pipeline, we can also use the functionality of our Pmid piping interface. For this, I just select the entry for the pipeline which is necessary to create, and if I have selected it, I am able to use the functionality which the software provides to me. Here we select the function create tube subassembly. That means if I now click on this function, then the software creates a new subassembly, and in this subassembly I am able to create the pipeline path, and to this pipeline path I can create the 3D pipeline and place the additional components, like for example the valve. I start this function, and if this is done, the software creates a new entry in my Pathfinder. This new entry is a new assembly, which to get the same name for the assembly file name that is delivered from Pmid from the pipeline number. So this is also an automation which we provide to solve some user typing mistakes. So that means with this automation there is no need to type in some values, and if you not have to type something, then there is no possibility to do mistakes here. In this subassembly we now able to create the pipeline path. And from the Pmid mask we can see that we have to create a pipeline path from this valve, 3D assembly valve, to this vessel. So from the Pmid I get delivered from where to where I have to draw my pipeline path. And with this information I go into my subassembly with the edit mode. Now I'm in the subassembly and I need access to the connection points of the environment components. This we realize by copying a reference component where all connection faces are included via interpart copies. Now we start drawing the pipeline paths. To this we switch to the express route environment, and there we start the drawing functions. To draw the path we have several possibilities. For example, to draw single line segments, or to use the path express. This is a kind of auto routing where the software gives me some information about possible connections. To this I select the first connection point here on this valve and the second connection point here on the vessel. The path expressed to show me some possibilities. I can influence some values and I can see a next possible solution or a previous, and with this function I can click through my possibilities that Path Express does give it to me, and if one of these possibilities does fit with my requirements I can say finish, and after that the path is drawn, and if this path is not 100% that what I like, then I can change also these paths. Perhaps I can say I like to connect these 2 points without one additional line. Additional to the creation, I can dimension my paths. Here for example I need a distance of 500 millimeters from the nozzle of the vessel. And if this required path is finished, I can stop the drawing functionality and can work further with my piping functionality. In piping, I start the analyzing of these existing line segments with the function generate pipeline paths. And now the software does look from a logical point of view on these drawn pipeline paths, and then a pipeline path is generated from the logical point of view, not only from the 3D line segments. And if I leave the express route environment, I have access to this actual displayed pipeline path, and with these paths we can work further. If such a pipeline path does exist, then we are able to bring information from the Pmid to these pipeline paths and then to create automatically the pipeline from it. But let's remember what's available for this pipeline path from Pmid. In this mask we see that there is a pipeline number 135 and the diameter of DN80. But there is additional information available that we can transport from the Pmid level to the 3D level. So let's take a look into the Pmid. Here we can see that to this line there is also this information about the pipe spec which should use and additional information. And we will see in a few seconds that we can transport this information also to 3D to work further with it. So to bring now the information from Pmid level to this drawn pipeline path, we just have to assign the information. For this we have the function called setPipeClass to pipeline, and if I do this to this pipeline path, then the software does assign both informations together. A message gives me the information that it is done, and additional to the message I now have the display of a green check to this pipeline. And this is the information to me that now the information from Pmid are assigned and defined in 3D environment. In my piping mask I see the display of the number together with the pipeline diameter, and the only thing which is not done in 3D now is the creation of the 3D pipeline. For this a user just needs to demand the generation with this button Recalculate Pipeline. If I click on this button, then the software starts with their automated function, and for every entry you see here and the progress bar you see working, the software does work some automated function, and if these functions are finished, then the pipeline is generated and created with the knowledge from Pmid also in 3D. And if for example in the used pipe spec there is a definition about the welding split between fittings and pipes, then also this parameter will be used from the software to generate the pipeline. In general, the software works always in the same way. That means, at first, during the generation process, the software does analyze the path of the pipeline that the user have drawn, and then the software take a look into the situations and positions which are available there, and with this information the software places the required components automatically from the pipe spec and the library in the background onto the pipeline path. And here every component is the same fitting with a different occurrence. That means the part is just placed one time but on different positions. These things are all done when the software does work through the progress bars from step through step. With the pipes it is a little bit different. That means every pipe on every position on a pipeline is a different and specific pipe. That means a specific file, and every pipe to have his own information and his own properties. So here we can take a look into the file properties of such a component, and here we will see that the software does write and know, for example, the standard from where this pipe is used, the geometric and the diameter for the pipe and the wall thickness. These informations we automatically write into the component when we create the pipeline during the generation process. And also some additional informations in kind of custom properties we do create during this process in the pipe components. And here, for example, we see the pipe class from where the pipeline is generated with, or the actual length of the pipe, or some additional information. And here we also write in information that are required if we like to generate automatically the isometric drawings at the end of the process chain. This we will show you at the end of the demo. So all this information we provide to the components, to the files, to the objects which are part of a pipeline. And with this information other process steps can work further. So we can see with this workflow of pipeline creation we are very fast and process secure because we work with pipe class specification in our software. But now let's come back to our Pmid connection in the piping application. In our Pmid connection we can see the pipeline is done. The pipeline in 3D is also generated. We see in the piping mask with all the required fittings and pipes. And from the Pmid we get delivered that one additional component is missing now because here we have not a green check in this mask visible. So when we click on this entry we can see the informations that transferred from Pmid to the piping or 3D environment, and here we can read that this, for example, is a valve. And normally a valve is a kind of inner equipment, that means it belongs to a pipeline. So if it belongs to a pipeline and if this valve does also belong to the pipe spec where we worked with at the creation of the pipeline, then we can use these valves very easy also from the pipe spec. If this is not the case, that in your company or in your department valves do not belong to the pipe spec, then you have to place these valves now manually and interactive like I show you with the vessel. But in our case it depends to a pipe spec, and because it does depend to a pipe spec we can say place this fitting to the CAD environment. By clicking on it the software does automatically place the 3D model in my working window, and I now have to place it on the position of the pipeline where I like to have it. During this also the piping software tell me that the required information from Pmid are now assigned to this 3D model. So I close this with OK, minimize my windows, and now I place my component with pure and native solid edge functionality and constraints to my existing pipeline. This 3D model we can recognize is stitched with capture fit functionality, and though it is very easy for me to place it on the position of my pipeline. And if I say I like to have it in one specific position, I can define some information about distance, about other things. And if the relations are made and the component is in the required position, then I can end the placing process, and then the component does belong to my pipeline. It is also recognized now as part of my 3D pipeline, and additionally it is also recognized as done in the Pmid application. So for this information that are delivered from Pmid into my 3D environment, we can say that this pipeline is done with the information. But additional to that, in 3D we can recognize that, for example, some informations or components missing, the flanges at the connection of this valve, for example, this is controlled and driven from the pipe spec, and the update to this we just have to demand with the function called Recalculate Pipeline, and with this my automations and my plausibility checks does run again. You can see it with the progress bars, and if this is finished, then I get an updated pipeline where my pipes cut it into pieces and where additional flanges are placed to my components fully automatically. So for the state now, we can see that the information from Pmid are all green checked, and the informations in the piping mask are also up to date because there is no different symbol or message available. So before we go further, let's take a look on the whole pipeline. And here on this end of the pipeline we can see that something is not okay. Here we can see that the valve is larger in the connection like the flange of the pipeline. How can this happen? Yeah, it can happen in the way that these correct information about the situation, that means here is a different diameter than here, so we need a reduction or a kind of different connection, that this information is actually not known from the system, not known in the piping information system, and also not known from the Pmid, because in the Pmid we can see that all information which is available is transferred, and with this information we worked in the piping application. So where is the reason of this not correct situation? So I think the reason is that the correct situation is not defined, and if it is not defined, then the software can't work with it. So let's take a look in the Pmid. In the Pmid we can see that this pipeline do have a diameter 80, and the information on this valve and on the pipelines of the valve are the informations of diameter 100. So it means that here a reduction from diameter 100 to 80 is missing. So this we like to solve now. For this we place a reducer symbol for a reducer component. We can control the scaling, the rotation, then we place it into the pipeline and define the diameters which we need to have from 100 to 80. And if this information is placed, we have this information in our Pmid, and now we see here the correct result. This we save and go back to the 3D. In 3D we open the Pmid connection, and here we refresh the content. And if we have the result from the refreshing process, then we will see that there is now the additional component, and that this additional component is a reducer component. So now we transferred the knowledge from P&ID to 3D that we have to produce a reducing or expanding situation on these connections. And this we can do now with our applications. To produce the reduction or expanding situation, we have to define where we like to expand or to reduce. For this, we go back to ExpressRoute, and in ExpressRoute we create the split point for this. If the split point is created, we dimension the distance, and now we have the split point. This is a point where we like to reduce our pipeline, or we like to expand our pipeline. If this is done, then we can select the existing pipeline path and start the reduction or expanding functionality. With this functionality, we have access to the used pipe class specification and to the definition of these pipe class specification. And here we see the available steps from where to where we can reduce or expand. So we know that we have to expand from 80 to 100. That's the reason why I select this entry. Go on OK. Then the software asks me about the connection point, where I like to expand or reduce. I select this point. And at least the software asks me about the renaming part of the pipeline. That means the part which should be or leave in the diameter like it is. In my case, we like to leave the pipeline part 2, is now highlighted in orange, and we like to change the smaller part of this pipeline. And if we go on OK, then my automations are start. If the software finished all the processes and all the automations, we can see the result of our expanding or reducing process. During this process, there was the message about non-unique fittings, where I have to define which kind of fitting I like to use for the same situation. And in my case, I use the favorite because I just clicked on OK without a specific selection. So now we reproduced the correct situation in the pipeline. Now we can close the ExpressRoute environment, go back to the subassembly, and from the P&ID interface we can assign the required information also to this reduction. So in this way we produce the pipeline with the information which are delivered from P&ID. If there are additional things required for this kind of pipeline which are not delivered from P&ID, for example insulation or similar things, then we can do this without the P&ID connection, because like I explained at the beginning, this piping functionality can also be used without the connection, if this is allowed for the user and if this is requested. To generate a pipeline insulation, it is very easy. For this we start the function generate insulation, and with the knowledge from the pipe specification and the selection to generate this insulation, the software does generate it fully automatically without some specific requests of diameters, of wall thickness and so on. And if it is finished, or the process has finished, then we can see the new components, the new isolation components generated around the pipeline. And here separate insulation components are generated. The parameter and the geometrics are delivered from the used pipe spec we have assigned from the P&ID. And all these insulation parts do also carry information about properties, about length and so on, if it is prepared in the required way or some specific information here. Also the definition if, for example, this valve should insulate it or not is also done in the pipe spec we work with to generate the pipeline. So here a user and an administrator have a lot of possibilities to control the behavior of the piping software to his requirement. In our Pathfinder we have now one assembly which does include all the required components and pipes and fittings that must belong to such a pipeline. And if we leave back to the main assembly, then we see that the main assembly do include more than this one pipeline, and the same process step we have seen for this pipeline now we like to create and we like to use now for the second pipeline we have to create with the information that are delivered from Pmid. Before we go further now, we save our results. Then we take a look into our Pmid application or our Pmid interface. Here we can see from which component to which component we now have to draw the next pipeline, and with the function which are integrated we create the pipeline subassembly. It is now listed in the Pathfinder. We go into this subassembly with the edit mode. As next we include the reference component with connection points. And now we can start creating the pipeline path. We change again to express route. Using our path express. Selecting the connection points. Defining some required values. Let's display the possibilities how to draw the path, and if this possibility is good for us, then I click finished and set some specific dimensions. About further dimensions, if the path is drawn and dimensioned, then we stop the path drawing using our piping functions to create the pipeline path. Do assign my information from Pmid, getting the information that the assigning is done. Now we can leave express route, and normally now we can demand the creation of the 3D pipeline. But in the case of this pipeline, similar to the first, we see now that all informations are assigned or coming from Pmid now assigned to the 3D pipeline. But here we see that the valve we have also in the first pipeline now is to do. And the question now is, must this valve also placed somewhere in the pipeline if it is generated? Or is it required to place on the position where perhaps the automated creation pipeline is not correct? What I mean is, for example, if I use the automatic generation before I place a valve on the position, then additional to this flange of the vessel we get automatically a flange again. But if my valve should now place directly on this vessel flange, then it makes no sense to generate the pipeline before and to delete the flange and then to update the pipeline. No, here in this case it makes more sense to place the valve before. This we do also with the function we know from the first pipeline creation. We place the fitting into the CAD window. The attributes from Pmid are assigned to this model. We get the green check here in the mask. And additional to that, we place the component which is teached with capture fit function to my required pipeline path. And with normal solid edge constraints, I place the component in the position where I like to have it. And if this is done, then I can demand the update and the creation of my 3D pipeline. And during this process, now all the required components for the new situation are automatically placed, and so I get a finished generated pipeline with the information that come from Pmid into my 3D assembly. But at the end of this, we have also the same information like at the first pipeline. And here a user can decide if he is responsible for creating a correct situation or if it is required to change the Pmid. Now for this sample, I like to use the workflow that the user is responsible for changing this, and for this we can minimize or close the Pmid connection. And now we solve the problem with the normal piping functionality. First we go into ExpressRoute environment using our split functionality, splitting the pipeline. After this we set dimensions. And this is done. Then we can work further with the piping function. After that we select the pipeline path, start the reducing function, selecting the required diameter, selecting the connection point, define the remaining part, go on OK to start the process. If the new diameter to have different parts defined for the same position or for the same standard situation, then a non-unique fitting dialog do appear and the user have to select his required component or the standard that is defined, and then the process works further. At the end of the process we get also the corrected situation for this expanded pipeline. Then we can leave the ExpressRoute environment, and in our Pathfinder we see our pipeline assembly where all components which must belong to this pipeline are included. If there is a need to change some pipeline paths or some specific diameters, then this can be done with pure piping functionality. But with a connection to a Pmid and the information we get now displayed, we can say that the pipelines are finished with the state of Pmid. After that we can close this mask, leaving the subassembly, and as a result of our work we can see the two additional subassemblies here and there. And with these subassemblies we can go to the next process steps. The last step in the process chain now is the creation of the 2D drawings. Here we have several possibilities. One possibility is to create normal CAD drawings in solid edge from the whole plant or from single pipeline subassemblies. And with the last created pipeline subassembly I like to show this to you. We go into this subassembly with the open mode. And with the standard solid edge functionality to create drawings, we can create new drawings from this subassembly. We use the standard function of the assistant, selecting our custom view, selecting additional views, can select the scale, the visibility, the shading, and then we place it into our assembly. So in this way we can create solid edge drawings, where we can also create, for example, part lists from these assemblies. And then we can place the bill of material. And all the content in this bill of material can evaluate it in the way that we use properties from the pipeline and from the piping software. Here, for example, the length that we have with the pipes and the tubes is delivered from the piping software. This is a standard solid edge functionality to create 2D drawings of single pipelines or the whole plant. If this kind of drawing is not enough for you, then we can offer the third step in a process chain to create the isometric drawing from this 3D pipeline assembly. For this we use the product IsoEdge. The IsoEdge product is also an add-in application to Solid Edge, and it is the interface between Solid Edge and the IsoGen, which is the kernel in this software application. This IsoEdge is normally a one-button solution for the end user who likes to create the pipeline as isometric drawing. But in general, there is a need to do a prepared configuration from an administrator or a key user. That means this application can customize to all the needs. For example, with the settings here in the mask, but also with the IsoGen styles, which represent the result in kind of a drawing. With these IsoGen styles, a company can influence the display of their drawings with the lists which should display it on the drawings or the drawing header and so on. These IsoGen styles are delivered with the software. There are delivered about 10 such styles, prepared styles with the software itself. And a company can change these prepared styles to their own needs. And normally if a user works with this application, then in this list there are the required styles prepared, and the user just have to select with which style he likes to create a drawing now. In our sample we like to create a cut list drawing, so I select this entry here, I save it, and then I have some settings which content I like to have in such drawing, more pipelines in one isometric or some similar settings. The end user just have to push on the start button, and then the isometric generation does start. And if there is a message about finished in this status bar, then normally in the output folder I get my required drawing. And for this here we have a DXF file. And when we open this DXF with a free of cost viewer, then we can see the result of our pipeline here with the whole content and the symbols and the whole information about the components delivered from the 3D pipeline. Here we see elevations, we see east and north direction, we see dimensions. We also see the lists which are prepared in these templates or in these styles, the kind of quantity counting in these lists and similar things. Also the drawing header and the cut list does depend on your definition and your configuration of the styles itself. So that means the display of this drawing and the look of the tables and the look of the drawing header is dependent on the style you select here, but the result of the drawing itself is 100% controlled from the 3D assembly that we have created with Smap 3D piping here. The isometric generation is the last step in the process chain in plant design area, and with this I finished my presentation. Here we can see the result of the 3D plant, which does now fit to my P&ID definition. Yeah, and together with Isometric Creation we can deliver all required functions and products to give you the possibility to realize this process chain in your company. During my demo I hope you get an overview about the application and their connection between the application and the workflow, how they work together. Now I will thank you for your interest, and if there are questions, please contact your next salesperson or contact us over our websites. Thank you very much and goodbye.